Okay, welcome whoever watches this video, and welcome Shirshanka, who is a guest that I have on today. Shirshanka, do you want to introduce yourself first?
Hey, Eric. Super happy to be here. I'm Shirshanka, co-founder and CTO at DataHub and co-creator of the DataHub project. Prior to this, I was at LinkedIn, where I spent a lot of my energy trying to make data engineering and data scientists work with each other. And I think we'll talk a little bit about that today. Interestingly, I also spent a lot of time trying to get product engineers and legal and compliance and security people to talk to each other. And that's probably another thing we'll talk about today. A lot of that led to the creation of DataHub as a project at LinkedIn, pointed it initially at discovery problems, and then over time pointed it at compliance and governance problems, and towards the end pointed it at ML and AI problems. And then I left and started DataHub, the company, to take DataHub forward. And 4.5 years later, here I am, still chugging along, making DataHub do great things for data engineers and ML practitioners. And we're here to talk about some interesting developments. And it's an amazing time to be building. So happy to be here.
That's a great intro because, yeah, making those personas talk to each other, they normally don't. Like,
Yeah.
when do legal people understand what columns are in a database? And you also were at LinkedIn. Isn't LinkedIn where you made your first iteration of DataHub?
Yeah, I was at LinkedIn for more than a decade, almost 11 years. And
Okay.
DataHub came out of a lot of that firsthand experience of trying to solve just internal problems. Like problem one was we don't even know where all our data is. And we were doing this complex Hadoop to Teradata to back to Oracle to like multi-warehouse transition. And we were trying our best to keep it all in order and help people find out where the trusted data assets were. And that was just the beginning. Over 6.5, 7 years there, it went from being just that search and discovery tool to being what we now call a metadata platform.
Nice. I have lots of follow-up questions for later. And I should probably say what we're even talking about. I think I just dropped you in the intro space and you had to introduce what this conversation is even about. So I'll introduce myself and explain why I thought it would be cool to have this conversation. My name's Eric Riddock, and I've done ML stuff for my whole career. And my whole career has been relatively short compared to Shirshanka's. Right now, I'm the director of an ML platform team at a company called Pattern. Pattern's the biggest seller on Amazon, besides Amazon themselves. We don't actually sell any of our own stuff. We only sell other people's stuff. It's difficult to succeed on Amazon. Amazon is a very clunky platform with a lot of decisions you have to make, like ad spend or processing returns, or like if you order a Pokemon toy and that is able to get to you same day. The reason that was able to get to you same day is because there's probably a warehouse physically located somewhere close to you. And they had some of those Pokemon toys in stock. And so one of the things that Pattern does and what the ML side does is we do demand forecasting, where we predict how many toys need to be in the London warehouse on Christmas Day or sometimes similar. So that's why this is a data problem. And my whole career, the topic we're going to be talking about today is data lineage. In the last 2 or 3 years, not having data lineage has become like probably the single biggest source of stress for me. And Shirshanka works in that space and has many thoughts about how this can be solved. And something that I think is really interesting is most of the industry doesn't seem to care about data lineage. It's kind of like observability. A lot of companies don't care about observability until it's too late. And especially, like, let's say you find a company that's willing to think about observability. Usually it's the data engineers talking about that, not anyone in the data science org. And it's funny and a little bit crazy because like data science, probably more than anything else, is an area where you really care to know like where your data came from and where it's going. Anyway, so I think this is a new conversation. I haven't seen anything like this online where I represent a person who's been struggling in the ML world, and Shirshanka has this tool that is usually associated with the data engineering world. And it's like, how much should data scientists actually be caring about this? And what can Shirshanka tell us? And also there's this cool technology called OpenLineage that people have questions about. So we'll talk about that too.
Data lineage is definitely a triggering word for a lot of CDOs and head of data platforms because they worry a lot about whether they have it, and they worry a lot about what happens if they don't have it fully complete and fully accurate. When I was at LinkedIn, my first stint, I started out in the online data infrastructure space. So I was actually not a data engineer by training. So I was building distributed systems for a living. And that's what I built for LinkedIn initially. So LinkedIn.com was trying to get off of Oracle to handle the scale that we were seeing. And so I was part of a team of really great engineers who were tasked with getting LinkedIn.com off of Oracle and building a new distributed system while we were at it. So it was a pretty fun project, a source of truth database called Espresso that we built. And then I worked a little bit on our CDC, change data capture system, the one that actually got changes out of that database and then fed it downstream for real-time processing, as well as for offline processing. And a lot of LinkedIn, of course, at that time was already ML native or predictive ML native. We were running real-time inference. We were running sometimes real-time training. And of course, we were running real-time feature registries and feature management, essentially derived standardized profiles for members so that we can recommend jobs to them correctly and things like that. And my later stint, really 6 years at LinkedIn, was spent on the data platform. And that's when I realized that while operational and streaming data was exciting and interesting and challenging, you were looking at 5 nines and tail latencies and optimizing for those kind of problems. The analytical world was complex in a different way. You were no longer looking at request response latencies, but you're instead looking at throughput. You were looking at how many joins can I perform in a second, or and how much Spark and Hive on Tez were fighting it out. And that's probably dating me, but that was the era that I moved into what was then known as the offline data infrastructure team. And interestingly enough, data lineage was not a problem we were worried about at that time. And I see that playing out even in the data maturity journeys of a lot of companies when they're starting out early on in their data lifecycle. They're not really worried about data lineage. They're just worried about what transformation tool are we going to use, what shiny toy are we going to use for visualizing all of this data, and now what AI model are we going to use to make answering questions of our data easy and delightful. And so initially, a lot of these companies, and us included, pursued more of an inventory strategy, which is just give me all the stuff that's in there. So in fact,
you're talking about discoverability. Like, how do I search the data I even have?
Correct. Like, and we often talk about this phase as the yellow pages of data stage, where you're just saying, give me the inventory. I just want to go somewhere, search for classic customer, revenue, orders, these kind of names, and I just can find the authoritative source of truth or the trusted asset for that. And it feels very much like a search problem, like a node search problem.
Mm-hmm.
So we did that, right? And that was the first iteration of the problem. But then very soon we realized that trust is not derived just from the identity of the node itself. It is actually derived from the relationships that it has with the nodes around them. Relationships are super important. And no surprise, Google figured it out with PageRank. And Lineage is not exactly PageRank, but in many ways, the understanding of lineage drives understanding of what derives from what. And that understanding then drives trust in whether an artifact that you're about to consume is actually the right artifact. Because you may not trust this artifact yet, but you might trust an artifact that's upstream of this artifact. And so that the transference of trust via lineage is a very important problem that we discovered just as part of the discovery problem. But that's not something that the leaders usually think about. Honestly speaking, and now I can say that with confidence, having been a leader. I was an IC my whole life, and then DataHub has helped me realize how CXOs think. We're usually thinking about top line, and we're thinking about how quickly can we produce new stuff reliably. And productivity is a means to that end, but it's not the destination. And so no one wakes up saying, oh, I need a data discovery system so that people can discover things quickly. They wake up thinking, why aren't we producing 10 more AI applications every day? And then they ask their underlings, what's blocking us from getting there? And one of the things that has happened is people have finally woken up to the realization that looking for stuff and just the booting up of context is a problem that really affects productivity, reliability, and quality. And that's one reason why data leaders are taking notice. But the second one, and probably the more important one, is just regulatory pressures. Right, the EU Act and the GDPR and CCPA and all of these regulations have really made it pretty clear that you can no longer just ship stuff to production and say that it's probably all right. And so a lot of that has led to the realization. And we see that a lot in the DataHub community as well as in our customer base. We tend to attract a lot of financial companies, companies that are using data operationally. And we wondered, why were we seeing this very interesting skew in the people who seem to hit this problem early, the companies that seem to care about this problem early? And the reason,
Regulatory pressure.
I mean, that industry is highly regulated. It's also very data driven. The biggest hedge funds in the world and the biggest banks in the world, nothing but giant data intelligence factories. And so their entire kind of top line and their efficiency is measured by how quickly are they able to turn facts into insights that they can then monetize.
Yep.
The moment that realization happens, that real revenue is tied to the quality of the data and the operational reliability of the data, and you're in a regulated business where billions of dollars are at stake, data lineage matters. And so that's what we're seeing in kind of the upper half of the stack, like in terms of the big companies. But what is interesting to me, Eric, is that even in the smaller companies, the companies with 5 data engineers, like Notion was an example of a company like that. Of course, super successful company, but the data team was super small. But when they started playing around with DataHub, they actually cared a lot about data lineage. And it was interesting to me that they cared about it so much, because at that early stage of maturity, you usually don't. And what they described to me was that there was a lot of trust issues with just the downstream analysts who were trying to consume the data. And they would always hammer the central team with questions like, hey, where was this derived from? What calculation are you using? And the calculations are usually spread across multiple layers, so it's never really the final layer that has the full details. And so to answer all of those questions, it was easier for them to self-serve by just giving them the DataHub lineage page and saying, go figure it out. So that's what we've seen in the classic BI-ish world, I would say.
Yeah.
But I think AI adoption is creating a ton of new complexity. And I'm actually curious, Eric, because you popped up on the community, 2 months back?
Mm-hmm.
And you were like, hey, I'm Eric, and I'm playing around with DataHub, and I'm loving the tool so far. I still remember that first message because it was an insanely cheerful message. Usually people pop up on DataHub Slack, and they're like, hey, this thing is not working. Someone help.
Yeah, these things become like a support channel, and
and for good reason, right? People are trying to get DataHub up. They're trying to do something with it, and they have a question. But you were like, hey, I'm excited about this tool, and I think it drew a lot of interest. So tell me a little bit about that journey. I'm very curious.
Yeah. Like, I won't say the whole story, but I think DataHub may have just saved my job. So like, let me step back for a quick second, because I think the way this conversation has gone so far is I introduced myself, Shirshanka introduced himself, and then he started to talk about data lineage and why people care. And then he represented what is the CTO's concern? The CTO is concerned about top line revenue and velocity, basically. And probably a third one I would add is stability. CTOs get headaches when you find out you lost $250,000 last week. So that's the CTO concern. And then part of this conversation too is like, why would ICs care? Why would data science ICs care about data lineage? And why would data engineers care? This is where I can tell you my story. Starting at my last company, I have some non-slides that I made for a talk I gave. Okay, so I'm not going to go through nearly all of this. There's just some points I want to hit. But something I don't think people realize, I last week met with our CTO, and I was trying to pitch to him why we should have a company-wide data lineage tool. And one of the first questions he asked was, we've been having a lot of outages. What does an outage mean in a data system? He's like, are things slow or are things breaking? And I was like, no, actually, it's much worse than things being slow and breaking. Like in data systems, failures are usually silent. I ripped this from a Datadog presentation, but I was watching this talk where Datadog showed this UI that kind of looks like Airbnb. And on the landing page, they give you some recommendations of some nice places you could stay at. And it looked nice. I mean, $200. I don't know if that's cheap or not, but all the recommendations have 5 stars or 4.5 stars. So they're recommending places they think are nice. And it's like, imagine if you showed up on Airbnb.com and the landing page showed you look, this beaten down hotel that's like 2 stars. That's probably really sketchy. I can imagine that Airbnb would lose a lot of money if something like this happened, because the web page is available and it's up, but the first point of contact for customers looking for listings is surfacing bad listings, and they're probably not buying them. And so they're probably losing a whole bunch of conversions that they'd otherwise be getting at the site. So it's like the website's up, and that's almost worse than it being down, because if it were down, there's at least no risk of me having a really negative experience with this product as a customer. And so where I work, we had an outage where nothing went down, but we lost $250,000 over a weekend. Because what happened was we have these automated pipelines that make smart decisions about how much money we should bid on keywords for advertising, which is a pretty classic data science problem. And there were some nulls in a data table somewhere that should have been zeros, but they were nulls. And so it made it look like the conversion rate for a given keyword was like 80% instead of 0.8%. And so our advertising spend pipelines went crazy, and they were like, wow, like we could make so much money if we go bid on these 80% conversion rate keywords. We're going to get rich. And so they made these wildly misinformed decisions, spent a whole bunch of money. And of course, the real conversion rate wasn't 80%, it was 0.8%. And so we lost a ton of money just basically making bad bets. And so what I think people don't get is in ML systems, especially, I mean, and I don't want to say that ML engineers are more special or less special than data engineers. Data engineers have this too. Like maybe this is a simple data engineering system here that had an outage being like something happened leading to bad quality data showing up where it shouldn't be. And that causes loss to business, not in uptime, but in bad decisions being made. So it's like the
Oh,
cost
yeah,
of bad
absolutely.
decision is usually anyway. So
Yeah, as an industry, I think we focused a ton on kind of model drift detection, right, as a problem statement. But we often find that data quality issues cause far more ML failures than model drift ever does.
absolutely.
I was watching the ML teams at LinkedIn because they were our stakeholders. And every once in a while, we would have an embarrassing failure. And it was never someone chose the wrong algorithm, or it was never someone chose the wrong
Totally.
weights. It was always we were processing weeks old data and we didn't realize it, right? And the warm signups metric was just tanking, and people you may know was not working. And it was not because the algorithm suddenly stopped working, it was because the data was just stale. And so a lot of the learnings I had at LinkedIn really was that you cannot treat data discovery, model discovery, model lineage, model observability, data observability as you cannot treat them as distinct problems. They're
Totally.
all
Yeah.
connected, and the graph is super important to get right.
Yeah, it's just on an interesting side note. Our company has an office in Pune, India. And so we're actually restricted to only hiring people onto my team from that office right now. And actually, for many months, we've had a job listing open for a staff engineer position, like a staff ML platform engineer. And to this day, we've not chosen to go forward with any of the candidates we've seen. And something interesting that I've noticed in that hiring market is most of the candidates we get come from consultancies. And a lot of their career has been they succeed as soon as a model is up. Like as soon as they have some sort of endpoint with a model baked inside of it and it's deployed, the project's done and they get paid. And so I'll ask them questions about operating a system after deployment. And it's just funny how that immediately becomes an edge of their knowledge. So one of the common questions is like, well, how would you monitor an ML system? How would you make sure that it stays up and is good, like is producing good decisions? And everyone says, well, I would look at data drift. And I think there was data drift, I think got famous during COVID when Zillow lost like tons and tons of money because the housing market post COVID was so different from before COVID, and they were automatically buying houses and they made a bunch of bad bets. And so a big issue with that is maybe they should have retrained their models in the post-COVID world. It got so bad that I think their CEO has a statement saying like, I don't even know if guessing how much to spend on a house is even a business we should be in, which when I hear that as a data science practitioner, I'm like, it sounds like my team is about to get cut. Anyway, I think that made data drift really, really popular. But what's interesting is to this day in my career, I've never seen a production issue that was due to data drift. Every single time, it was due to something like nulls that should have been zeros. It's always some basic data quality issue. Maybe there's an upstream source of data that feeds into an ML system, and someone made a code change that accidentally turned null, like zeros into nulls, or or maybe something happened from the vendor you're getting the data from. And so it's just one thing that I've noticed when interviewing people is like most practitioners who've been working on ML systems, we all have had that insight. We've all seen, yeah, this is where the majority comes from. And so one of the things we notice in our interview process is like when someone says, oh yeah, I would look for data drift, but then you push them and they actually have no idea about this other thing, like where the real source is, it kind of signals that like maybe they've never done this before. Like maybe they've never actually owned a system before. Anyway, so
Yeah.
interesting thing.
Yeah. When I think about kind of the Maslow's hierarchy of like sequencing of things that you should do while getting an AI or ML application live, you really need to make sure your inputs can be trusted. So you have to build those data quality checks first.
Yes.
then you build performance monitoring, and then you build drift detection. It's kind of like, for me, it's always been that's the sequence of steps. And if you skip one of them, especially the first one, then you're in a world of hurt because you could
Totally.
be abandoning good ideas without even realizing it.
I think the saddest part of all this is creating checks to make sure your data is good quality is actually really boring. It's really, really tedious, actually. Anyway, that's a whole other conversation. So I want to tell another story, and then I'll try to talk much less in this conversation. So this is the story of the last company I worked for. So back in 2018, 2019, the company I worked for, it's called TubeBuddy. It was a Chrome extension that helps people succeed on YouTube, basically. So we give you like analytics to help you make your YouTube channel better. And that's a big data problem because there's a lot of creators on YouTube. There's a lot of content. There's a lot of comments and things that we were using for analytics. And so we wondered, where are we going to put all this data? And data lake houses were like more emergent then than they are now. It wasn't as clear, like, oh yeah, go with Snowflake, go with Databricks, whatever. Use Iceberg, use Delta Lake. And so we decided to go with something we knew. And we just grabbed a Postgres instance from AWS. And we were just like, we know Postgres, we'll stick our tables there. And I actually don't think that was a bad call. And we started.
Yeah. In fact, most people do Lakehouse too early.
That's a cool comment to be able to be here with the CTO of DataHub and have you be able to say that. Yeah, so like the way our history kind of worked is, we created a data pipeline, and the data pipeline got data from somewhere, probably like social media, and like loaded that data here. Maybe it was information about YouTubers' videos. And then so we had this data engineering system that got us this data, and then we had like some UI that consumed it. And that was like our Chrome extension. And back at that time, there was this big surge in platform engineering. Like, let's get rid of data ops, let's get rid of MLOps, and let's do data platforms and ML platforms. Let's make it really easy for these teams to create pipelines so we can get this data in. And so we did. We made it really easy to create pipelines. And so, yeah, this is how an ML pipeline might fit into the picture. Here's our data pipeline. Here's our table. Maybe an ML pipeline grabs stuff from this table and outputs inferences, like maybe predictions, customer clustering, or something like that into the second table. And then, maybe you add more apps and they're all consuming this. And if you make it really easy to build these pipelines, then what happens is you get a lot of pipelines. And so over the course of 5 years, we had tons of data pipelines, ingesting data, transforming the data. We had tons of ML pipelines doing this advanced analytics, and we added some more UIs as well. And we added a lot of tables. And what was funny is everyone here had good intentions and good motives. So no one here is evil. But one of the things you would do if you were a product manager and you wanted to push a new feature across the line is you would, like, the engineers would come to you and they'd say, there's probably a table here that already has the data you're looking for, but I don't know where it is. And I don't know how good it is. And so oftentimes the way that conversation would end is the product manager and the engineer would decide to just add yet another table, probably duplicating the work someone else had already done. And so, like, if you wanted to ship a new feature, you sort of disregard everything that was already there because you couldn't find it, you couldn't trust it, and you had more tables. And so over time, our database grew and grew and grew. And it's funny because a lot of AI teams talk about like GPU spend and like fancy tooling for experiment tracking. And like our single biggest cost as a team wasn't GPUs. It was actually this Postgres instance. Like, it grew to be like $250K a year because every time this thing ran out of memory or ran out of space,
You had to vertically scale up.
it was like, yeah, what was our option? Like, it was like either we do a full migration out of this now or finally untangle this spider web, the spaghetti, or we just make it bigger and do it again later. So, I mean, I was present multiple times when we sized this thing up. And I was grateful that we were willing to do that because I didn't want to go unwind this. And so, I mean, we were using Airflow for data pipelines and Metaflow by Outer Bounds for our ML pipelines. And that was tough too, because if we wanted to have some sort of lineage story to help us with this, it's like we needed that lineage to span different tools as well. And
By the way, Eric, a quick anecdote. Do you know what's the number one system that DataHub gets connected up to for extracting metadata?
I have to assume Airflow. Is that not right?
It's Postgres.
No way. Wow. Because people have like a database with a soup of tables in it, and they're like, please query this thing and tell me the lineage.
At least they're getting the inventory out of it.
Yeah. Okay. Nice.
Yeah. Because they have tons and tons of tables in Postgres, and they really need that discoverability. So that first problem statement that you said is like probably like the number one use case for DataHub in the wild. We don't see that as much with our customer base because they're like a little later in their journey, and so they've kind of migrated out of that single instance kind of pattern. But in open source, we see a ton, like it's the number one ingestion source used by far.
I think what analysts want is analysts are always like, well, what data do we have? And if they want the answer to that question. You'll give them the answer to that question using some sort of data catalog tool, and that's when they discover that the data is bad. But they don't discover the data is bad until they know where to look for it in the first place. So I can see why that would be the first question a company's trying to solve. Sorry, go ahead.
Yeah. So something that's interestingly happening nowadays a lot is that same journey that you just described, where someone says, I got to build a new app and I need to either look at existing tables that might have this information or just create a new table.
Yeah.
That kind of pattern that used to repeat itself every time humans wrote new code is now repeating itself every day because AI is writing most of the code.
That's fantastic.
And so what
So
is happening is, and Neon said this in their kind of, I think maybe a year back or 6 months ago, that agents are generating 4x more tables than humans were. Just the rate of creation of tables, so DDL statements, I guess, was 4 times higher than what humans were doing. And we see that quite a bit with people who are either community members or customers, where they're starting to use Cursor or any of these AI IDEs to actually just produce new data transformation code. Of course, there's a human driving that project. There's some AI model involved in doing the driving for them. And what they're finding is that when they connect up the DataHub MCP server,
Mhm.
then that problem statement that you just described of going in, looking at what exists, understanding what tables already exist, what they look like, etc., is happening really organically, and the human doesn't have to go do this elaborate song and dance, log into the UI, search for stuff, do that kind of research. The model is able to do that research very quickly on the human's behalf. And so we're starting to see some really good results as long as you have that DataHub MCP server connected up to your AI IDE. And so I think that's super exciting what that means, because humans are fundamentally lazy and they're fundamentally short on time always. But as long as their AI IDE has the tools it needs, I think a lot of the good practices that we've always wanted humans to do can probably be realized now.
That's cool. Like GitHub Copilot or Cursor can reach out to your data catalog and look up your tables. That's great. I think
So you moved to Airflow and Metaflow, but you still had the single Postgres instance, and then you started trying to solve for Lineage.
Yeah, eventually Databricks enters the story, and we were like, well, what if we wanted to migrate this to like one of these modern data lake houses? Because like our size is
Sure.
big, we should
Yeah.
go there. And so then it's like, so think about this. Not you've thought about this. Audience, think about this for a second. Well, it starts from the data. So I'm like, I have this table, and I don't want it to be in Postgres anymore because it's big and it's expensive and it gets queried a lot. And now people are telling me this thing called the data lakehouse can allow me to like query it with like unlimited concurrency, and it'll be cheap because I just pay for compute, not storage. And all this stuff. And it's like, okay, so let's say that's table 4. If I want to migrate table 4 to this data lakehouse and get it out of Postgres, what's the process for that? Well, probably like I probably need to take the code. Maybe it's an ML pipeline that writes to table 4. Or maybe it's multiple. Maybe multiple processes are inserting to table 4. I probably have to have all those now insert not into Postgres, but into the new place. So I need to route those. But wait, where do those pipelines get their data from? What if this pipeline writes to it and it's getting its input data from table 1? Then I have the same problem. I actually have to go back a degree and traverse the graph. And now I have to ask the same question about table 1. Like, okay, what's writing to table 1? And so it's like the same problem that the microservices world has. Like if you have a whole bunch of microservices and you want to migrate from like, I don't know, AWS to Azure or something, and you have to change your microservices domain, like URL as you go, you have to sort of like
Understand the call graph. Yep.
Exactly. Like, and it's painful. And even when we had a new lakehouse tool, the data engineering team was like, okay, we're ready, move. And it was just like, we don't know where to start. And this is a big effort. Like we have 5 years worth of pipelines that we're potentially moving. Like, where do we go? And so it's really funny because we talked to NewRelic about this problem, which is like a classical observability tool. And OpenTelemetry was hot. And so we instrumented our services with OpenTelemetry, cool. And OpenTelemetry like basically lets you instrument application code and log a whole bunch of observability data to one or more backends. In the standard way. And so what's really funny is we're like, so this was like our trace graph we instrumented with OpenTelemetry. So it's like, have you tried tracing? And then this is what OpenTelemetry ends up showing you. And it's like, it appears you're hitting the lakehouse. Like that's pretty much what it gets you. But it was like, thanks, we knew that. We knew that we had pipelines that were reading and writing from this. So there's a new, I'm not saying this is the end all be all answer. Actually, this is kind of a topic maybe we should debate. But there's OpenTelemetry for services and requests, what OpenLineage is for data sets and pipelines. And of course, DataHub has been out here doing this since before OpenLineage was even a standard. But this is really cool because OpenTelemetry, I believe, in the CNCF org, I think it's the #1 CNCF project by commits right now. It's really hot. Like the industry is all over OpenTelemetry. So if there's this thing called OpenLineage, which is similar, then you would think that this can be similarly big, like can do a similarly big thing. And so OpenLineage has like a similar idea. Like you take your data pipelines, like wherever you're running your SQL or your ML models, whatever's doing reads and writes to your lakehouse, you instrument that with OpenLineage instead of OpenTelemetry, or actually both, by the way, but you can do OpenLineage. And then there's one or more backends you can send that OpenLineage stuff, but it's nice because maybe you're not locked in. Like maybe you could send stuff to DataHub, or AWS has this tool called Data Zone. There's Marquez. So there's like multiple choices here. And the promise of this data observability is that if you instrument with something like this, you can get a graph that looks more like this. Instead of seeing one service reaching another service, you can see a job, like something that does a transformation on data, and then you can see the data assets that the job inputs and outputs, which is amazing. And this is amazing, and it's also kind of insufficient, but this is a great start. Like if migration is your problem, this is at least the map that tells you where to start. This is kind of insufficient for more mature operations because as soon as you have this chart, you then want to ask questions about stability. It's like, okay, I know that table A is a dependency of table E, but how do I get told if table A breaks? Like, how can the owner of table E be known? So there's like a monitoring and alerting question there that something like DataHub helps you with more. Sorry, go ahead.
Yeah, so with DataHub, I think there are two different pieces here that are worth kind of celebrating and reflecting on. The first is that lineage as a concept used to be something that we used to kind of aspire to talk about and say, wouldn't it be nice if we had it among the IC crowd, right? And then as that conversation went higher up, most of the leaders were like, I have some other projects for you guys to do. But first thing to celebrate is that's no longer the case. People actually do care about lineage now. The second thing to celebrate is that people have a lot of choices now for what to even use for extracting lineage or producing lineage. And that I think is phenomenal because 2021 is when DataHub commercially got started. Of course, before that, we were at LinkedIn for 6 years before that. And lineage was a pretty hard problem back in 2020, 2021 when we got started. It was a hard problem. There were entire companies just built on the lineage promise. They were not labeling themselves as a catalog. They were not even a metadata platform. They were just lineage. What has happened over the past 4 years is that because this problem has emerged as an important problem, platforms like Snowflake and Databricks, and also the open source products like Airflow, Daxter, etc., have kind of said, no, we got to participate in making lineage more accessible. And of course, customers have had a huge part in making that happen. In terms of how, though, like the how of lineage, creation, I think there are different approaches that people have taken. In systems where data is mostly at rest, or data at rest systems, like if you take Snowflake as an example, sure, tables are getting transformed all the time, but Snowflake is primarily a table as a first-class citizen system, and then everything else is on top of that. They think of lineage as just a feature of their access history table. Right? And when we talked to Snowflake in 2021 or 2022 about getting lineage out of their system because they were working on a more accessible lineage APIs, they said, well, here's our table. It's going to have all the queries already pre-parsed for you. And so it should be super easy for you to extract lineage out. And similar things happened with Databricks as we started integrating with, the Unity Catalog APIs and things like that. And so the platform started growing up and started realizing that lineage was a first-class construct that they needed to expose to external systems because customers needed to see that cross-system lineage. And then OpenLineage was created. And OpenLineage, from a premise perspective, I love. The idea of standardizing metadata exchange across platforms and systems, a great idea. In practice, though, just like what you were saying, Eric, I have noticed that it leads to, at least for the consumers, and by that I'm talking about myself as a consumer of metadata coming out of different systems, it actually unfortunately results in more work when it
Yep.
shouldn't. When you look at that beautiful diagram of lots of producers producing into a single open lineage box, and then downstream live a bunch of happy consumers that are just nicely consuming those open lineage events, and beautiful graph is getting constructed. Reality, unfortunately, tends to be a lot more complex than that, because exactly as you said, once you get these edges together, the next question becomes, well, who owns that table? Who owns that
Exactly.
pipeline?
Right.
How often does that pipeline even change? And what is the team? And what data does it have? And is there PII in that table? And the moment you start asking those other questions, you realize that unlike OpenTelemetry, there's actually a central flaw in the open lineage idea. The central flaw in the open lineage idea is that lineage is a standalone concept and can be standardized. It's kind of like saying that I'm designing my data warehouse. So imagine you're in a big company and you're saying, I'm going to design the data warehouse for my business. And I'm going to take my standard for how to define a login event from a different company or a different project. So that one project has standardized how logins look like across the web. A LinkedIn login and a Facebook login, and then all of those login events are going to look exactly the same.
Yep.
I'm like, amazing. We've standardized one event out of the thousands of events that my warehouse needs. And it might seem like a win. Like that first graph does get constructed quickly. But then you realize, wait a minute, I just got one fact standardized, but I now have to join these facts to dimensions. And now I have to rationalize the fact that some of the dimensions are in the facts, because that's what we do as modelers, right? I'm producing a login event for a person. Maybe I'll include their first name and last name in that login event. Maybe I'll also include the country that they're logging in from. But then separately, I have a record for them in the database that actually has everything else about them. And so those IDs have to line up. And if all of that stuff is coming from, so now let's get back from metaphor to the real world, where let's take Airflow as an example.
The metaphor you're saying, you're talking about the benefits and the pros and cons of standards. And you're saying, here's another example of a standard, and it's modeling login events the same way, but it falls short because it describes login events, but there's all these other kinds of events out there. And now you're about to say, okay, let's take this back to Lineage. Sure, we've standardized some bits of Lineage that you can express, but there's more. Is that right?
Yeah, the real problem that we've noticed when we integrate with systems like Airflow or anything that produces open lineage is that we get a part of the picture, but then to get the rest of the part of the picture filled out, we anyway have to go to the source system
Yep.
and either pull or push that stuff out. So it
Yep.
kind of ends up being double work for the consumer, right? So for DataHub, we anyway have to build either pull or push based connectors for Airflow to push out DAG run information, as well as DAG definition information, as well as all this other stuff. And in
Absolutely.
addition, we also have to stitch in the information coming from open lineage if the producer is producing an open lineage. And so that ends up being like a double mapping exercise where you anyway have to fetch the raw data from the source system, and then you have to almost merge it in with the data you're getting from open lineage. And so in a strange way, so that's why when we give recommendations to customers or community members, we say, well, if DataHub has a native connector for this, just use it, because
Yep.
then it gets everything that we need.
Yep.
But if you are already producing open lineage and you care about producing open lineage, sure, we have an open lineage endpoint that'll at least get you some of the information you need. But guess what? You'll have to supplement it with either pull-based extraction or some other push-based emitter anyways. So then we have to also layer on the additional piece. So that's what we've ended up finding as a practical reality, which is that standards are good, but then they have to be complete to capture every use case that is downstream of the standard. And
Yes.
unfortunately, every use case that's downstream of the standard is the entire metadata graph problem, which means over time, you'll be forced to do what DataHub has been doing anyways, which is describe data sets and schemas and partitions and models and features, and then describe changes to these. You have to model the whole graph. You have to model every single change that can happen. And only when you've modeled the entirety of the schema, the data warehouse schema for metadata, and you've modeled every single change that can happen to it, have you truly accomplished the completion of your goal so that any downstream use case can be accomplished. So that's been my practical kind of, because I have a broad use case downstream of this, right? If you've got a super narrow use case, like coming back to our login event scenario, right? If someone was saying, all I need to do is count the number of logins that are happening across all the social platforms, then a login event standard is great because you can build that one, counter, and it can work across all of the login events. But the moment you go, oh, I need one more piece of information, and it's not coming through as part of the standard, then you put pressure on the standard to add that. And my bet is the more you put pressure on that standard in a metadata sense, it'll actually be forced to expand unnaturally. And before we know it, OpenLineage will start including ownership information and business glossaries and other kinds of things because people will say, I care about this stuff. And
So
then it'll
actually,
feel awkward.
I really liked what you just said, and I think it might have gone over the heads of data science practitioners listening. So I want to try to restate it how I had come to it before this conversation. I had used NewRelic at my last company for like 2 years, and we were deploying all of our models using endpoint. We were using Fast API, we were using Bento ML. So all of our models, if you asked us the model deployed, what you were really asking us was, is there a REST API deployed? This model. We were using NewRelic to monitor all of those REST APIs. NewRelic has these SDKs, and so does DataDog. DataDog is like a stand-in for NewRelic. They have these SDKs you can use, and you can instrument your model endpoints to capture telemetry data from your endpoints, like how many requests are being made every second, how many of them are failing. If they're failing, what are the error codes? OpenTelemetry came out, and I was super stoked because I was so sick of being vendor locked into NewRelic. I was really annoyed by that because we were having to do some gymnastics to avoid putting any NewRelic specific code into our APIs because I didn't want our data scientists to have to be thinking about NewRelic. I wanted them to be able to just deploy their APIs and have like monitoring just sort of happen automatically. And so I was really excited when the standard OpenTelemetry came out because I was like, yes, like finally, like let's say we're using Fast API because we were for some of our apps. Like I was like, finally, we can use the OpenTelemetry plugin for Fast API instead of using NewRelic's plugin. And we can set up our Fast APIs with this. And now if there's something custom that data scientists want to track for their application, yeah, they have to use an SDK, but at least they're not using an SDK that's locked into NewRelic. They're using this like open one. But what we ended up finding was the community created plugin, like instrumentation for Fast API, it just didn't capture as much stuff as NewRelic did. Like it would maybe count how many requests you got, and it would tell you the errors. But one thing I took for granted with NewRelic is they did other things. They actually looked at what your CPU utilization was. They looked at your memory usage, and they just did all that for us under the hood, whether we were on Lambda or containers or whatever. I realized that there was a richness of data that NewRelic was capturing that OpenTelemetry wasn't. And then it's like, okay, let's say that eventually the community could build these OpenTelemetry plugins and get them to the point that NewRelic has. You still have to buy some sort of observability backend because there's a place you need to send that data to. And what those backends do is they give you analytics, they index your stuff, and they also allow you to organize the data. So like all this stuff from OpenTelemetry is like raw. It's like, here's a request that happened, request. And it's totally unorganized. Maybe in OpenTelemetry, you declare what service it came from, but that's kind of where it stops. In the service itself, you don't say who owns the service. You don't say, I mean, that's actually the biggest thing. You don't say, what product in my company does this service belong to? So there's no sense of grouping or tagging. And this is something that I actually don't think it makes sense to express in a standard like OpenTelemetry, because OpenTelemetry is just a standard that talks about raw telemetry. And so what I'm saying is like Datadog and NewRelic, they have these proprietary SDKs. And if you use those, you actually are able to express in the model that the vendor gives you that grouping related information, which is like really good. This is a buzzword that doesn't make sense, but it's good for operations. It's good for like when there's an outage on a Friday night, how do I find the owner of this service? Like, who owns it? Like, what human do I reach out to?
Yeah.
And
I
open,
think
so,
when
so
I see what you're saying, and I think the success of OpenTelemetry is because they didn't try to own and be an opine on the metadata model of telemetry.
yeah, exactly.
Like they didn't say what were the metrics that were allowed and what were the dimensions that were allowed. They said, as long as you can tell me what a metric is and what a dimension is, and you can emit using this, property bag roughly with some, metadata around it, we're good, right? So protocols work really well, especially fundamental protocols like
Mhm.
OpenTelemetry. They're designed kind of loosely like that, where they're dynamic and, the opinion can be on either sides of the protocol. OpenLineage, on the other hand, the opinion is baked in to the protocol, right? OpenLineage has a typed facet called dbt, and it's got like fields in it, and it's got a typed facet for, I think, Airflow, and it's got fields in it. So
Mm.
that's one of the things I've noticed that gets in the way of using OpenLineage as a protocol, because it's not something that I can just layer the DataHub metadata model on, because it has its own model definition for what dbt is and what Airflow is and Daxter is and all of those different things. And I think that's where the analogies stop
Okay.
between OpenTelemetry and OpenLineage. And I think that's been one of the reasons why it's been a little trickier to adopt OpenLineage as plumbing,
So interesting. Yeah, because like you would never see an open telemetry event that says fast API. Like
Correct.
you would never be reading the RFC for open telemetry and see an enum where fast API is like one of your options.
That's
But
right.
with open lineage, there's this thing called custom facets where developers on the Airflow project have actually created the Airflow event type.
Yep.
Okay, that's super interesting. And so
And so as these projects, now you put pressure as the project evolves, and maybe next month, Airflow launches a new feature called incidents or something, right? Now, guess what? Now, thankfully, well, maybe not anymore, but at some point, Airflow committers were also OpenLineage committers. So they would probably keep those standards in sync.
Mhm.
But, as that drifts, you'll see kind of impedance mismatch happening, because from information that's available at source and what's really getting funneled in through the protocol. And the moment that happens, people are going to switch and they're going to go direct to source. And that then defeats the point of the standard. So I think that's kind of one of the central problem with, and I say this personally as a person who loves standards. Like I always fight for a unified standard. I always love leverage, but this is one of the central problems with standards that bear kind of models. They get
Yeah,
in trouble because of this.
I think what you're saying is represented by this. It's like, there's the M times N and there's the N plus N. And like, if you want to have M things producing data and N things consuming that data, if there's no standard, every producer has to know how to send to every consumer. But if there's a standard, maybe each producer plugs into that, then every consumer just plugs in. But I think what Shirshanka is saying is that like, because you actually see Airflow specific events in the standard, all the tools actually have to understand, like, okay, let's say Airflow comes out with a way to log an incident that happens on a table. The consumer actually has to update the way they consume open lineage events to accommodate Airflow. It's like the Airflow way of doing an incident instead of like the generic way of doing an incident.
Right. Like, firstly, OpenLineage has to evolve. So the lineage producer has added a new field, really, that they
Yeah.
are producing, or a new kind of thing. OpenLineage has to evolve to then carry that new field. And then the consumer has to evolve. Consumer evolving is totally fine, right? The consumer evolves because they need the new information. What usually happens is the producer has evolved, added new features. Consumer wants to evolve and get access to those new features, but the standard isn't evolving that fast and it's not able to keep up. And it's kind of the central problem with standard management, because if your job is to essentially model the universe of all tools that people are developing, then you're at the mercy of every single tool's metadata model evolution. So every month, every system is adding new concepts. And so you have to continuously evolve. And that's a tricky problem. It's easier if the protocol was a bit more open, so that producers could evolve and produce new concepts without the standard having to get in the way. So maybe that has already happened, to be honest. I've not kept up with OpenLineage as actively. So perhaps OpenLineage allows that already, but that was one of the things I noticed about when we implemented the OpenLineage integration, was that in real life deployments, we were having to do OpenLineage and DataHub when OpenLineage was involved. And when
Yeah.
OpenLineage was not involved, we were just having to do just DataHub, meaning just the DataHub pipe, because DataHub gets everything out that it needs anyways, and that's continuously evolving. So
Yeah.
as a consumer, it's been beneficial in certain scenarios where we didn't have to build a connector because that system already produces OpenLineage. So it's good to get us off the ground in some new projects. But from a final production launch of a connector, we always end up finding that we have to get in and actually build native connectors that supplement or complement or fully replace what OpenLineage gives us. So that's been kind of our experience as downstream. As much as I love the idea of standardizing metadata, that's been the practical challenge that we faced.
Absolutely. Yeah, I was going to say, I don't know the state of OpenLineage, but one of my frustrations with OpenTelemetry when I first was working with it is like, they describe 3 types of data formats: traces, metrics, and logs, and I guess baggage as well. And when I first started looking at this, it was pretty recent. It was like 2022. The state of the standard was considered unstable and alpha. And so there weren't a lot of vendors consuming OpenTelemetry or even producing. There weren't good integrations to produce OpenTelemetry stuff because the community didn't think it was worth investing because the spec wasn't stable. And so it's actually been like super recent. Like I'm actually really surprised. I was just checking this. Logging is stable. I had no idea that the logging protocol was stable. Like last I checked, which I think was just last year, OpenLineage did not yet have stable opinions on how logs should be represented. Where was I going with this? Oh, but the thing is, the spec was allowed to evolve. And it's like, as soon as it becomes stable, everyone gets excited because now they don't have to do it in their bespoke way. And so let's take the concepts of incidents, for example. I think there's still room for OpenLineage because the thing is, OpenLineage is actually very new. I think it's only like 3-4 years old.
Yeah.
And so it makes sense to me that they would start with the things that are most fundamental, like jobs and data sets. And, they don't yet have a standard way of representing machine learning models, for example, or incidents or owners. And like, you know what? I bet that these are all things that the community generally wants. And if a day comes that OpenLineage decides that there is a standard, like basically what I'm saying is there's room for them to introduce these standards and then for Airflow to like deprecate basically all of its custom fields and stick them, like start representing them as the standard. I think that'll just take time. What do you
Yep,
think?
yep. I think that's generally what happens with standards. They kind of take a little bit of time to mature, but then as newer systems start up, they can kind of snap to the standard more easily.
Yeah.
And so hopefully we'll see that happen. Like I really want standards like OpenLineage to do well because it actually benefits both the producers as well as the consumers. And a lot of the realization of that will depend on the how of how it's built and the trade-offs that the standard makes in terms of how loosely to model things and how extensible it is. But I'm sure it'll get there.
Yeah, I think a fair statement is OpenLineage actually has a lot of the same strengths and weaknesses as OpenTelemetry compared to what vendors offer. Like
Yeah.
vendors, I mean, let's be real. Vendors would like to lock us in. Like that's a moat. That's a good thing. However, it's not
Well,
that.
DataHub is open source, so technically, unlike
Yeah,
Datadog, which is backed by a proprietary system, DataHub is very different. DataHub is a fully open source, Apache 2.0 licensed, front to back. Like none of the code base is even slapped on with an SSPL or anything like that. So it is literally an open source metadata platform with a metadata model that anyone can use or extend, and that's what we find people doing. Like Netflix literally runs DataHub at scale, and they've extended its metadata model to add concepts like experiments
nice.
and pages and things like that. So I think the comparison with DataHub and Datadog as vendors is not exactly correct. But
That's
yes, you're right about the
a good
lock-in
clarification.
concerns.
That's a good clarification. Like, because I wasn't even about to say, all vendors are evil. What I was actually about to say was like, actually, vendors are put in a hard spot because if you're a vendor and, like Acral Data is, like the managing, if you want to get managed data hub, you can go with Acral Data. And so, you kind of benefit from having this tool lock-in moat, which is fine. But if you ask Datadog, do you want to log people into your SDK? They actually have a really reasonable answer, which is actually OpenTelemetry is really unstable. And if you want enterprise grade premium observability today, we're like, our proprietary tools are literally 10 years ahead of this open source standard. So it's like, you have to sort of pick, like, do you want agnosticism or do you want the best experience? And that's kind of where we're at, like, at least with OpenLineage right now.
Right, right, right. But I think with DataHub, you can kind of eat your cake and have it too, because DataHub, the vendor, invests a significant amount of research and development into DataHub, the Apache 2.0 open source
Right.
project, which you can run and manage yourself, and there's no risk of lock in there. You can continue to evolve the project, you can fork it, take it wherever you want, and so there's a lot less kind of nervousness that we see around that aspect of Data Hub.
Totally.
I am more than happy to see standards like OpenLineage evolve, and like we recently rolled out our Iceberg REST catalog because we saw that the Iceberg standard has taken hold. We have integration with MLflow, and some people have asked us to build an MLflow compatible backend. So I think the way we look at the world is we want to meet systems where they are. And so
Yep.
if systems like producing to a certain API or consuming a certain API, then that pops up in our list as something worth interoperating with. So from that perspective, OpenLineage for us is very similar to Iceberg or MLflow or other kind of systems as
Yep.
a important integration point that we need to be partnering with and building good integrations with.
And it sounds like as OpenLineage gets better, I think DataHub celebrates that
Exactly.
continuously.
Yep.
But until that day happens, DataHub is in the business of offering the most premium experience you can get with Lineage. And so in the absence of standards, they're going to have their own model. And I think that's okay. I think
Yeah,
that's great.
we have to.
Yeah.
We can't wait for a standard to evolve for us to then provide end-to-end lineage. And lineage is just, like I said, one of few different relationships that are important. We have to capture the whole metadata graph of metrics and dimensions and ownership and
I was going to
parent-child
say,
relationships and all of the above.
I grabbed this from the DataHub docs. This is actually the entity relationship diagram of all the bits of metadata that DataHub can talk about. It's a lot. Like OpenLineage has jobs and data sets, and these are all the things that DataHub has a distinct concept of, like a dashboard and a chart within a dashboard, and an ML model as well, and like feature that goes into an ML model. And then another thing is, we talked about the ownership. You can tag stuff and declare things as owners, or you can have incidents there. Those are all important concepts to talk about. As some competitors to DataHub start to do the same sorts of things, the OpenLineage people are just waiting for proof about which of these entities the majority of people care about, so that we can agree on it. Over
Move
time,
it in.
more of these boxes will show up in the OpenLineage spec.
Yeah, I think that's probably right in terms of how the world evolves. And very soon we'll start seeing Gen AI artifacts in this, by the way. So like,
Yeah.
prompts and LLMs are going to show up in this metadata graph, Eric. So don't be too scared.
Totally.
We'll have to serve this using a real app very soon. And probably that app will be DataHub.
I think I'll tie up at least like the model part with the, like, what did my team care about at work right now? Like the lineage graph, I mean, it's cool, but it doesn't help my team win yet. I think my team needs a little bit more to get value out of data lineage. And that's actually why we're probably going to use something like DataHub. And one of the biggest things is it's one thing to know what data sets go into my pipeline. That's fine. But I need to know if I can trust them. I need to know if they've been tested and if there's an active outage right now. And if there is an outage, I want to be told so that I can not go blow a bunch of money on Amazon keywords this weekend. And so I think some of the most important concepts that a lineage tool needs today, that DataHub has, is I want to be able to assign an owner to each who in the business to talk to upstream or downstream of me. I want a concept of incidents, and I also want a concept of measuring the data quality, and that's where basically unit tests, like assertions on the data sets. And actually, we did I want to give a plug to DataHub right now. Actually, one of the things that I spent the last 3 weeks on was this POC where there was a bit of pressure internally, should the entire company be using Airflow? And the implication of that is even data scientists. And that's something that I'm allergic to. I really don't want data scientists using Airflow. And there's a whole discussion around that. But we desperately, I think, need data lineage. And so it was like, if I, as an ML platform person, am saying, hey, let's let data scientists go off in their own land and do their own thing on their own pipeline tool and not use the pipeline tool the data engineers are using. If that comes with this consequence, oh, and by the way, we're not going to be part of your lineage graph, then that's not acceptable. And so the POC we did, we actually ran DataHub and some other backends as well. And we stood up Airflow, we stood up Metaflow, and we got the lineage to show up.
Nice.
And we had to write our own OpenLineage plugin for Metaflow. Airflow already had one, but Metaflow didn't. And so,
Nice.
so there it is. There's Lineage in DataHub. Here's model outputs and here's Airflow outputs. And you guys don't have the Metaflow icon, so we use the SageMaker icon instead.
Okay.
And here's AWS Data Zone, which is the Lineage backend. So here's us sending all this OpenLineage data to Data Zone, which is cool. But you know what? Data Zone doesn't do what DataHub does. Assertions and ownership. Data Zone doesn't have that. So by the way, if you were comparing tools, that's a deal breaker for us in Data Zone. But here's another cool thing about DataHub is like you can express these assertions about data. Like here's a unit test. The column total rides should have a row count greater than or equal to 5,000. This is failing. There's all these data quality tools. There's Great Expectations, there's Soda, there's Evidently AI, and all of those can operate on SQL tables. For data science, we wanted to operate on data frames. Evidently, AI can operate on data frames. There are other reasons we didn't go with that yet. But we wanted a data validation tool that wasn't Great Expectations because we just wanted to pass in our data frames to be tested before we even wrote them to the database. And so we actually had to write our own tiny little library that like could run some data quality checks on data frames. And what you're seeing here is actually the result of our in-house bespoke data quality validation tool, but the tests show up in DataHub and you can see one of them failing. And this could actually cause an alert to someone downstream to be told that one of these data science tests is failing, which is, it's amazing because we're using something so bespoke and yet we can still play in the Lineage space and we can even do assertions. And so it's DataHub, like it seemed like a really well-designed tool. Like I was really pleased that it was easy for us to log our own custom metadata in here. So anyway, just shout out to you guys for making the API so good to work with.
Yeah, very cool to watch. We definitely try our best to make it API first in everything we do. So it's actually model first. You can extend the model, and then the APIs get derived from that, and then the UI gets built on top of that. So essentially, we always try to make sure that you can get any custom metadata in there in the kind of the skeletons that or the templates that we set up. And so this is very cool to watch. In fact, a lot of our customers do a combination of this. Like they'll have DBT tests. They might have Great Expectations. They might have their in-house thing, like you said. And on top of that, they might be using DataHub's Clouds Observe features. And they don't have to do all or nothing. They can just add them all up. And so they can do some data quality checks inline. They can do some data quality checks after the fact, like using anomaly detection or things like that we have. And so that ends up being a very nice way of having control over the points that you want to have control over, and then letting automation take over the things that you don't have time for. So we've designed it explicitly for that. And pretty much all of the metadata model concepts in DataHub are built for that. Like our MCP, which is not MCP AI MCP, but metadata change proposal, which is our fundamental event that you emit. It's essentially the broadest event structure that you can have, because you can essentially produce anything that DataHub recognizes, and you can make ownership show up, and you can make a new table show up and a new schema show up.
Yeah, one thing I noticed was like OpenLineage has this concept of like custom facets. So you can basically design your own custom objects that you send as the OpenLineage events. And actually, when I was looking at the data model, like down to the JSON of what you're sending to DataHub, it actually seemed very similar. I was like, wow, DataHub actually seems to think about representing data very similarly to the way OpenLineage did. And when we were writing this plugin, I mean, our code is still very much hackathon level code. There's going to be some effort here polishing this integration, but
it's probably pretty easy.
That's what I'm trying to get at. It's like, because I am worried about tool lock-in. And even though DataHub is great, there's a part of me that hates that I'm using a DataHub SDK when I could be using this open standard. But the lock-in's not that deep is what I'm trying to get at. Anyway, so it's a great tool. We haven't bought it yet, or we're not self-hosting it yet. And I think technically, even within my company, we're still doing some evaluations. But in the evaluation process, this has been our experience with DataHub. And I just think it's a really well thought out tool. Another thing to say is DataHub has been thinking about this the longest. There are some other vendors, but like Shirshanka said, they started out as just Lineage or just data catalogs. And DataHub is kind of always, well, it's had an evolution where it's become all of these things and it's stayed open source the whole time. So it's just, I don't know, it's a really good tool for people to know about, I think. One thing I will say, the install is very heavy. There's Kafka in there. There's Elasticsearch, which has the licensing stuff. There's a SQL database in there. So self-hosting is kind of a beast, but it is a good tool.
Yeah, it's the cost. We're trying our best. If you look at the latest Quick Start release that's coming out, we're dropping schema registry and a bunch of those unnecessary dependencies from the list of containers. So yay for that. The DataHub Cloud instance actually runs on OpenSearch, not Elastic. And so you can actually run DataHub on OpenSearch too. But you're absolutely right that it has a few different systems that it relies on. And unfortunately, that complexity is the reason it scales. It's a double-edged sword. That's one of the reasons why Apple and Netflix can really scale it up and run it at scale. It's something we think about quite a bit, yes. But
To that
the
point,
edge,
too, like imagine if Datadog went open source. Like Datadog is a beast of a tool. You have to think their machinery is crazy. And like think of the number of events people are emitting to Datadog. Like if you're doing Datadog badly, then probably every single time your API does a request, you're hitting Datadog. Like that's millions of events. And
right,
you might say
right.
to yourself, well, this is just batch. This is just Airflow DAGs that run every day. But that's decreasingly true with like real-time systems. Like what if you have Flink and every time Flink does a micro batch, you want to report an event?
Correct,
And
correct,
so
correct.
like,
Which
so
is why
actually,
Kafka was important for us, because we wanted to make sure that you could just send a fire hose of metadata events and never get, stuck
right.
in a write to, Postgres taking too long.
Yeah,
But,
the speech I just gave was me making myself feel better about, the emotional trauma I saw when Kafka was in the stack. So
yeah. Well, Kafka is doing a lot to get out of the stack too, right? They acquired a company called WarpStream, which now runs Kafka on top of S3. And essentially, it's a serverless implementation. So there's a lot of like Kafka itself has gone through this journey of going from being an implementation standard to now being regarded more as a protocol standard. And so in many ways, there probably are a set of tools out there that are Kafka compatible, which means you can like drop in a Kafka replacement. Maybe it's being given to you by Confluent, or it could be a different vendor. I haven't kept track of all the streaming providers. There's probably serverless versions of Kafka out there that can then drop the complexity of standing up one of these systems even more.
another plug for the feasibility of self-hosting DataHub if you're allergic to vendors. And part of being allergic to vendors is procurement is a beast. And sometimes in order to even pass procurement for a person like me who has to fight for my own existence, because ML is sort of always this like unloved child in a company oftentimes, you often have to show that you're successful. You have to prove the value of the tool first through self-hosting before your company is even going to entertain a contract. And so at my last company, so the story I told about the Postgres database, by the way, the way that story ended is we actually one day just shut off the whole database because the whole data science team just got axed like all at once. So we all got laid off last May. And so the end of that story is we just turned off the database, which is great. But before that happened, there was a guy named Daniel Clark who was able to successfully self-host DataHub without Kubernetes, which is a big deal. Like he was able to put the containers on ECS. Kafka was like Amazon MSK, like Elasticsearch was OpenSearch. So he was able to do CloudFormation, which is a much more manageable thing for a small team than a whole Kubernetes deployment. And it was okay.
Cool. A lot of folks getting to success with it. And we're definitely looking at how we can make it easier for people who want to either self-host or get themselves kind of a starter DataHub instance without having to go through the kind of the big procurement dance. So stay tuned for that.
Well, this was you can tell I had a fun time. So this is an awesome conversation.
And you can tell I can go on for a while on this topic.
Yes.
So.
Before we wrap up, one thing this conversation missed is more things about why data scientists could care. So quickly rattling those off. There's this concept called target leakage, where like there's this story where like there was this model that was trained to identify if someone had diabetes or not. And the most predictive feature of the model was whether or not a doctor had prescribed them a medication for people with diabetes. It was like, you kind of gave your model the answer. One thing Lineage can actually do if you get column level lineage is it's easier for people to call you out on cheating in your model. And sometimes people do it intentionally. Sometimes people intentionally game their model performance. And most of the time it's unintentional. The Lineage space is kind of messy right now. If you go by Databricks, they'll tell you if you use Spark, you'll get you column level lineage. I think with the advent of DataHub and OpenLineage, one thing I'm hoping for is libraries like Polars, Pandas, and Narwhals. I'm actually hoping that these tools will become instrumented with like these lineage things as well. So if you're wondering about getting that DAG down to the column level for a data science project, imagine a day where instead of having to parse 1,000 lines of difficult, dense pandas code, you can just look at a graph that shows you what's happened to the columns. Like that will be the golden age. That'll be a golden age of data science for sure.
That would be very cool, indeed.
And compliance. That's the last one. So anyway, those are my last things. Is there anything you want to say before we head out? What do you want to leave people with?
No, this has been so great, Eric. We kind of danced around kind of first the problem of lineage, why people care, Then we talked about a bunch of tools. We spent a lot of time on standards and how they're
Yes.
great ideas, noble ideas, but also so hard to get right, and got to give them time. And then we talked about DataHub quite a bit, but mostly talked about the principles that make projects successful, I think, more than DataHub in particular. Extensibility, openness, and the ability to have good APIs are kind of super important for developers to really get those power user capabilities that they need. But hopefully the MLOps community loves what they heard. I mean, we've got an integration with MLflow as well. We see that used quite a bit for end-to-end Lineage and SageMaker as well. And Metaflow is coming up. So looking forward to that contribution. We've actually got 2 community members. So Eric, I got to line you up with someone else who's also working on a native connector with Metaflow.
Please, that'd be great.
So yeah, exciting times ahead. And I'm super excited to see all the places that Lineage will go in the next year.
Yeah, thanks for doing this. We should say everyone go join the DataHub Slack. If you want to go learn about DataHub, do the
Absolutely.
Slack. I think they would appreciate if you didn't just treat it as a support channel, but also share your ideas about what the future could be. Let's make
ask questions. We're in there, and we do respond. Also, start the GitHub project and definitely check it out. It's a beast, but it also does a lot in a very small amount of container space for what it's doing.
I'll try to make it to wherever we post this, we'll have some relevant links to the DataHub stuff. So anyway,
Awesome.